There are several parts to this problem, so let's get started. We are given a position function, and we're asked to find the velocity of the object. So we need to remember that the velocity is the derivative of the position function. So to find our velocity, we just need to take a first derivative of the above function. That's going to involve the power rule, which means we need to take this power of 2 and multiply it by this negative 0.3. Doing that gives us negative 0.6, and then we're going to take that power on t and reduce it from 2 to 1. The derivative of 27t is just 27. And that is it for that part of the problem. So let's move part 2 a little bit closer. The second question asks, when does the object reach its highest point? So your intuition might tell you that this object is going up and then it comes back down. And right here at this highest point, you'll notice something about the function of that object. More specifically, you'll notice that the slope of this position function here is 0 when the position function reaches its maximum. In other words, the ball goes up and then stops just for an instant and then comes back down. And just in that instant, the velocity of this object is 0. So we can use the result from the first part of this problem, plug in our velocity of 0, and then solving this equation for t gives us the time at which this velocity of 0 occurs. Or in other words, it will tell us when the object reaches its highest point. Solving for t gives me an answer of 45, and that would be seconds. So the object reaches its highest point after 45 seconds. On our graph, that 45-second mark would appear right here. And the next question asks us, what is the height of the object at this highest point? So we know that this object reaches its maximum height at 45 seconds, but what is the height? So do we have a function that will give us the height of the object? Yes, it was this original function back here, this s. So if we want to find the height of this object at its maximum height, we just need to plug our 45-second mark into that original function. The notation for that would be s of 45. And when I plug all of that into my calculator, I get 607.5. And we have to go back to the original problem for our units. It looks like our units should be meters as our maximum height. Well, now let's look at the next question. When does the object strike the ground? Well, what does it mean mathematically for an object to strike the ground? So the object goes up, it comes back down, and it strikes the ground right here. And what is true about that point is that the height of the object at that point is 0. So s equals 0 when the object strikes the ground. So what we can do is we can take that position function and plug in 0 for our position. We then notice that we have ourselves a quadratic equation. Fortunately, we don't actually have to use the quadratic formula. We can factor this. Now we've broken down this problem into two factors multiplied together, set equal to 0. So we can split this problem into two pieces. One piece says that t equals 0. The other piece says that negative 0.3t plus 27 equals 0. We can now solve this equation for t, and dividing 27 by 0.3 gives me 90 seconds. So this t equals 0 here tells us that the object starts on the ground. Then it goes up, it reaches its maximum, it comes back down, and after 90 seconds, the object hits the ground again. Alright, I think we have a couple more questions to answer. With what velocity does the object strike the ground? Well, we learned from the previous problem that the object strikes the ground at 90 seconds. If we want the velocity with which this object strikes the ground, we need to take our velocity function from above and plug t equals 90 into it. So I'll move that down a little bit to make a little bit of room. What was our velocity function again? Plugging that into a calculator gives me an answer of negative 27, and the units on that would be meters per second. Our velocity is negative because the object is coming down. All right, the last question asks us on what intervals is the speed increasing? And I think that we can use our intuition to answer this question, but I wouldn't be a very good math teacher if I didn't point a few things out to you. Whenever our object is above the ground, we say that its position is positive. Between 0 seconds and 45 seconds, our object is moving upwards, so we say that its velocity is positive. On the interval from 45 seconds to 90 seconds, the object is moving downwards, so we say its velocity is negative. And on this entire interval, our velocity is always decreasing. Another way to say that is that our acceleration is always negative. We can confirm that our acceleration is always negative because acceleration is the derivative of velocity. And if we take the derivative of the velocity function from earlier, we just get negative 0.6, which is always negative. However, this question asks us about the speed of the object, which is different than the velocity. Speed is the absolute value of the velocity. And I hope that we can agree that when this object goes up into the air, its speed starts off positive. Then the speed of the the object decreases until it goes to 0, and then the speed of the object starts to increase again until it hits the ground. So I hope that we can agree that for this object, the speed is increasing from t equals 45 to t equals 90. But maybe we can come up with some more general rules for when an object is speeding up or slowing down. An object is speeding up when either both its velocity and acceleration are positive, or when both its velocity and acceleration are negative. An object would then be slowing down when velocity and acceleration have opposite signs. Okay, I think this video has gone on long enough. I'm going to leave it there, and I will see you in tomorrow's problem of the day.